This module is focused on air pollution. It will be covering topics in chapter 10 of the book. And for this module, we should be understanding historically important episodes about air pollution, identify health effects associated with air pollution, list hazards just linked to indoor air, enumerate the main components of urban ambient air pollution, and we'll discuss this concept of climate change and global warming. Worldwide, many cities in the world do not meet guidelines for air pollutants for at least one pollutant. This is true in European cities, but overwhelmingly this problem is becoming worse in major urban centers in developing countries. In the United States, many cities, and about a quarter of the U.S. population, according to this time frame, do not live in cities that meet U.S. air quality standards as regulated by the EPA. Many pollutants that we might actually be able to visually see, common one that we think about is smog. It's a mixture of pollutants, usually ozone at the ground level, which produces chemical reactions involving nitrogen oxides, heat, and sunlight. And it produces this sort of misty, smoky-looking haze. Smog can be formed by human activities, or there are sources of things that allow smog to form that are natural. Some of the main issues with health effects from air pollution are lung cancer or skin cancer because of air pollution that depletes the ozone layer, but also damage to vital tissues and organs such as the nervous system or impairment of lung and breathing function. Outside of human health effects, we can also be concerned about impacts on our environment. Air pollution can cause damage to property. It can reduce visibility in national parks. If anyone's ever been to Smoky Mountain National Park, that haze that you see is the result of smog. It can harm forests, lakes, and injure wildlife. There are three main events that happened in history that pushed the needle on how we move to reduce air pollution. And the context of these events are that major urban centers in Europe and in the United States were doing a lot of manufacturing. They were producing a lot of products. Steel was one of the main things they might be producing. And most of the time, these air pollution events happen where temperatures changed, pollutants stayed close to the ground, it was likely winter, and not only were we having manufacturing putting air pollutants into the air, but also people heating their homes. People died because the air pollution. The composition of air without any pollutants in it consists of many elements: nitrogen, oxygen, argon, carbon dioxide, and other gases, as well as water vapor. There are many natural sources of air pollution: dust and wind that spreads dust, salt. As I mentioned before, there are some things that can form pollution, like plants can produce volatile organic compounds that produce natural air pollution or air pollution from natural sources, but also mold is a source of biologic pollution. Forest fires and volcanic eruptions both emit lots of different air pollutants that we might think typically are associated with human activity. Of course, Mount St. Helens is a very historical eruption, but in the last 10 years we've seen eruptions of volcanoes in Iceland that produce this type of pollution that cause air traffic problems, and they're releasing air contaminants as well. Human-made or anthropogenic sources of air pollution can be classified into two types: stationary sources, which means they don't move, they stand in place, and mobile sources, which is the one that we're probably most familiar with. Mobile sources include cars, but also trains, boats, and buses or other sources that move around, like maybe even construction equipment. Stationary sources are things like power plants where they're producing pollution, standing in place, even smaller production of things like at dry cleaners, they're releasing air pollutants as well. Generating plants, factories, chemical plants, and incinerators. Mobile sources, I mentioned on-road vehicles, off-road vehicles, and then non-road vehicles. Most vehicles produce our typical pollutants that we're concerned about. Motor vehicles release both volatile organic compounds and nitrogen oxides, as well as high levels of carbon monoxide, and they're responsible for other emissions of air pollutants as well. Common components of air pollution include sulfur oxides, particulate matter, oxidants such as ozone, carbon monoxide, hydrocarbons, nitrogen oxides, lead, and some other heavy metals. There are 6 pollutants called the criteria air pollutants that are regulated by the Environmental Protection Agency in the ambient air. And the Environmental Protection Agency requires states to monitor these pollutants by putting up stations around the city. If the states are in violation of these, they can be fined and made to change policies that will reduce these air pollutants. The 6 pollutants that are monitored on a regular basis are ozone, nitrogen oxides, carbon monoxide, sulfur dioxide, particulate matter 2.5, and lead. Particulate matter has 2 sizes, 10 and 2.5, and this is the diameter of the particle, micrometers. It's very small. Visible with the natural eye, perhaps, but very small. Both sizes cause irritation of the respiratory tract and impact the lungs, but the smaller size particles, particulate matter 2.5, which has a diameter of 2.5 micrometers, can go deep into the lung, and they're not easily removed from the body that way. They can often also have chemicals on their surface that then are additional insults. So it's not just the particle, but what the particle is made of. Particulate matter 2.5 is one of the contaminants that we're concerned about in terms of association with premature death. Acid rain is precipitation that is when it rains, there's pollutants in the air that become dissolved into the rain and change the pH of the rain. Sulfur dioxide and nitrogen oxides that are produced by utility plants like electric generation plants can create large quantities of these and then produce acid rain, and this can damage the environment as well as buildings and infrastructure. Here's an example of how the pollutants are emitted, and it can produce acid rain even far away from the places where the pollutants are emitted. A temperature inversion is a condition which a warm layer of air stalls above a layer of cool air, and it stops air from mixing, and it allows pollutants to concentrate in that lower layer of air, the one that's closer to the surface. Pollutants build up, they don't mix, they aren't dispersed, and it results in a high concentration of pollutants for human health. Diesel exhaust is generated when trucks or sometimes cars burn diesel fuel. It has additional contaminants that we're concerned about, including additional polycyclic aromatic hydrocarbons, which we're concerned about in terms of carcinogenicity, as well as other organic and inorganic compounds. There's a broad body of evidence that exposure to diesel exhaust is more hazardous than other sources of air pollution. That workers and railroad crews that were exposed to it have increased incidence of lung cancer. So we're very concerned about human ambient exposures as a result of diesel fuel burning in the US. This air quality index enables you to understand what your risk is if you were to perform certain activities outdoors, what the risk to school children are if they're outdoors, and it allows people to make decisions about those risks. The National Ambient Air Quality Standards are the set of standards that each state has to comply with, and these are revised periodically and often lowered to improve public health. There's primary standards, which are intended to protect sensitive populations such as asthmatics, children, and the elderly, and secondary standards, which are really about limiting property damage, damage to animals, crop, buildings, and that's really from things like acid rain. What are some of the acute effects of air pollution? Immediately upon experiencing it, you may feel irritation of the eyes, nose, and throat. Your lungs may feel aching. You may end up with cases of bronchitis or pneumonia, wheezing, coughing, nausea, and headache. But chronic effects can result in much more serious and not resolvable illnesses like heart disease, chronic obstructive pulmonary disease, or lung cancer. Although the United States does not have the challenges with indoor air quality that other countries face that I'll discuss in a minute, in the United States, we spend the majority of our time indoors, and so indoor air quality has become increasingly important. There's evidence to suggest that poor indoor air quality in buildings can make asthma and bronchitis worse. We know that certain types of cooling towers and water systems can spread Legionnaire's disease, which is an infectious disease spread through water vapor. Some people feel sick when they're in a building, and when they leave they feel better. This is called sick building syndrome. Sometimes there's a reaction or an allergic reaction to air quality that results in chemical sensitivities. Sources of indoor air pollution can be mold and bacteria. This is particularly challenging if there's ever been a flood or water seeping into a home, or the home's not properly ventilated with a HVAC system that maintains humidity at the right points. Carbon monoxide, fumes from attached garages, or improperly functioning furnaces are huge concerns. Chemicals released from building and furnishing materials. If you've ever had a new carpet installed or painted your home, they can release volatile organic compounds that can make you feel ill. Tobacco smoke, of course, even if you're not smoking, someone in the room is smoking. And then radon, which tends to have a low impact on a immediate scale, but long-term exposure to radon can result in lung cancer. In many countries in the world that are in developing nations, cook stoves are used because people don't have electricity or gas, clean natural gas to cook with. So people use all sorts of things like wood, dung, anything to cook with, and these fires are often unventilated and result in tremendous amounts of air pollution inside homes. This often impacts children and women, and it causes severe amounts of death and disease. As I mentioned before, indoor air quality illnesses associated with more like the developed world, we might see sick building syndrome, where while you're in the building you don't feel very good, but when you leave you feel better, or building related illness in which you're diagnosed with asthma because of time spent in a location, and it's typically related to specific pollutants like mold or bacteria. Global warming is the phenomenon that used to be the only way that we talked about climate change. It's defined as an increase in the near surface temperature of the Earth And we believe it's resulting because of increased emissions of greenhouse gases. Greenhouse gases allow the Earth to keep heat in and don't allow it to escape the Earth's atmosphere. And there's a general consensus, even as old as this version of the book is, that the Earth's surface has warmed by about 1 degree Fahrenheit in the past 140 years, but there's growing evidence that it's warming much more rapidly. Now, climate change has really moved from just talking about global warming to talking about all the variations we're starting to see in climate and how less predictable the climate has become. The major sources of air pollutants that can contribute to global warming include fossil fuels like coal-fired power plants or gas fuels like petroleum-based fuels. We know that chlorofluorocarbons, which have been used in coolants like air conditioners, have been linked to depletion of ozone layer, which can also allow for increased heat uptake. And this is just a depiction of what happens. So solar radiation comes in. If there's not a lot of these pollutants that can host the heat into the environment, it will escape. But much of that is now being re-radiated back into Earth and causing warming of both the surface of the Earth, especially with water. Impacts of this change include disturbance in habitats, growth of vector-borne diseases, shift in poisonings like seafood-caused poisonings. We believe that air pollution effects will be worse, and we will see more extreme conditions such as heat waves, droughts, and more erratic and larger storms and more difficult to predict. We see that because of things like heat waves and droughts, there may be disruption of the food supply and dwindling of food resources, which may cause civil unrest. In terms of air pollution in the U.S., we are a major contributor to the Earth's greenhouse gases. We burn a large number of fossil fuels, and coal-fired power plants contribute. We have a major role in putting out carbon dioxide, which is one of the gases we're most concerned about for global warming. What can we do to reduce air pollution? Energy conservation. We can agree to commit to national or international protocols where we will reduce our contributions to global warming. And we can also introduce technological controls that will eliminate or reduce these outputs into the environment. There are mechanical devices that can reduce pollution by scrubbing, filtering, or precipitating out the pollutants. I won't talk about Kyoto Protocol or the Copenhagen Accord until the end. Energy conservation steps include reducing the use of vehicles that are no longer energy efficient, better home construction, electrical appliances, increasing the fuel efficiency of motor vehicles like hybrid or high mileage, and of course, not using motor vehicles at all, but increasing the use for public transportation systems.